Hi, myself B.Devananda Rao, working as Associate Professor in the Department of CSE, MLR Institute of Technology, Hyderabad. Today's topic is SDT for counting number of ones in a binary number. Here, this is the syntax directed translation for counting number of ones in a binary number. That means there is a number n, n generates a list of bits. List of bits. Then L produces list of bits followed by a single bit, and L generate a bit, and B may be a bit, may be a 0 or bit may be a 1. These are the rules to generate list of bits. Then for n derives L, the semantic action will be n dot C is equal to L dot C. Here C is an attribute. C is an attribute. That means this attribute indicates count of ones in L. Here L dot C means count of ones in list L, that is assigned to n dot C, that is count of ones in n. Next, L derives LB. L dot C is L dot C plus B dot C. That means count of ones in a list and count of ones in bit, count of ones in B and count of ones in list both are added together and assigned to count of bit ones in L. Next, L derives B. The count of ones in B is assigned to count of ones in L. B derives 0. B derives 0, that is B dot C is 0. That means count of ones in B is 0, because whenever bit is 0, whenever the bit is 0, we should not count 0, because we are going to count the number of ones in the binary number, not 0. So that whenever bit is 0, the count of ones is 0. The count of ones in B is 0. Then B derives 1. Count of ones in B is 1. If the bit is 1, count is 1, like that. We will take one example string and count the number of ones in that. Take this 1101. Parsing the string by using grammar rules. N derives L, L derives LB, L derives LB, L derives LB, L derives B, B derives 1, B derives 1, B derives 1, B derives 0, B derives 1. Then while parsing through bottom up, B derives 1, B derives 1. The action is B dot C. That is count of ones in B is 1. Continue. L derives B, reduction. B is reduced to L. That means L dot C is equals to B dot C. B dot C is 1. Continue. Reduction. B dot C is 1. Continue. L derives LB. L derives LB. The semantic action is L dot C is L dot C plus B dot C. L dot C is 1, B dot C is 1. 1 plus 1, 2. Continue. Reduction. B dot C is, B derives 0. 0 is reduced to B. So, B dot C is 0. Continue. L dot C. L derives LB. L dot C is L dot C plus B dot C. L dot C is 2. B dot C is 0. 2 only. Continue. B dot C. B derives 1. Count of ones in B is 1, that is 1. Continue. L dot C. L dot C is L dot C plus B dot C. L dot C is 2, B dot C is 1. 2 plus 1, 3. Continue. N derives L. N derives L. N dot C is L dot C. L dot C is 3. So, number of ones in the binary number is 3. So, this is the translation scheme for counting number of ones in the given binary number. For example, if the question is like counting the number of zeros in a binary number, the SDT will be changed by just remaining first three statements are same, only these two statements will be changed, production rules and semantic actions. So, instead of this, B dot C is 1 and instead of this, B dot C is 0. Here, because for bit 0, we are counting number of bits 0 in B is 1. For bit 1, we do not count. So, that B dot C is 0. Another question may be like write SDT for counting number of bits in the binary number. Number of bits means both zeros and ones. For that, we need to change these two semantic actions. B dot C is 0 for bit 0, B dot C is 1 for bit 0 and B dot C is 1 for bit 1, because we are counting both number 0 and 1. So, that both count, B dot count is 1, B dot count is 1. Remaining parts tree as it is, we can go ahead. Thank you.